Hello class, happy Wednesday. Today we are going to go over a new chapter, lesson 11-1. We're going to be working with a lot of information about data and graphical displays. Some people say data, some people say data. I will be using the word data. If you look at our first lesson, at the top it says read line plots. So our objective is to read and interpret line plots. Our math words are line plots and data. Here's what the story says. A group of children listed their heights to the nearest inch. What does the line plot show about the heights of the children? A line plot uses X's on a number line to show data. Here in the red box it says each X represents one child. Since there are 19 X's, there are 19 children in the group. Then here is our line plot. Okay, we have a number line and we have X's representing children. This is representing the heights of children, and down below we can see that each number represents the height in inches. The shortest child is 46 inches tall, and the tallest child is 54 inches tall. And then there are children in between who are at different heights. Whoever is 50 inches in height, there are quite a lot of them. 1, 2, 3, 4, 5 children there. All right, let's go to the practice and see if we can use this line plot to help us answer the question. What is the difference in height between the tallest child and the shortest child in the group? Whenever you see the word difference, you know that you will be subtracting. We want the tallest child and the shortest child. Tallest child, we already said, was 54, and the shortest child is right here at 46. We always start with our larger number first. 54 minus 46. You are welcome to show your work on the side. If we were to do that, we know that in our ones place, we cannot take 6 away from 4, so we go to the tens place. We ask to borrow a group of 10. 10 plus 4 makes 14. Now I subtract, and I have 8. So the difference between the tallest and shortest child is 8 inches. Number 2, how many children have a height of 48 inches? Well, let's look on our number line. And when we go over here, we will find at 48 there are 3 X's. That means there are 3 children who are 48 inches tall. Next page. We have a new line, a new set of information. Students measure the lengths of some pencils. Use the line plot of the data to answer exercises 3 through 6. So now we have lots of pencils and we have different lengths of our pencils. The shortest pencil is 10 centimeters, because that's what it says, length in centimeters, pencil lengths. And the longest pencil we have several of them. 1, 2, 3, 4. 4 pencils were measured at 18 centimeters. So number 3 says, how many pencils are 16 centimeters long or greater? If they want to know 16 centimeters long or greater, that means that I start with 16 and I count everything from 16 on up. 1, 2, nothing here. 3, 4, 5, 6. So I have 6 pencils that are 16 centimeters long or greater. Number 4, how many pencils are shorter than 14 centimeters? So it has to be shorter than 14. So I cannot pick 14. It has to be anything that is less than 14. So let's take a look. I have 1 here. 1, 2, 3, 4, 5, 6. 7. 7 pencils are shorter than 14 centimeters. Number 5. Bianca says that the most common pencil length is 12 centimeters. Daisy says it is 18 centimeters. Who is correct? Well, let's see. Pencil lengths of 12 centimeters, I have 1, 2, 3, 4. Pencil lengths of 18 centimeters, I have 1, 2, 3, 4. Oh, they are both correct. Who is correct? Both are correct. Both have 4 pencils of those lengths. So of those lengths, 12 and 18, both of them have 4. Okay. Number 6. Sergio says that the students measured 8 pencils because there are 8 numbers with X's above them. Is he correct? Are there only 8 pencils that we've been looking at all along? He says because there are 8 numbers with X's above them. 1, 2, 3, 4, 5, 6, 7, 8. That means that we only are looking at 8 pencils. That would not be correct because we know that every X represents a pencil. Each X represents, big word. Remember, you can pause at any time. Each X represents 1 pencil. And if I counted, there were, I believe, 19. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, 16. There were 16 pencils. Okay, so there are 16 X's, which mean 16 pencils. You might like to write it a little different, but as long as we agree on the meaning, that will be okay. Now you'll notice that the third page I've given you in your packet for today is not the third page in the book. So for anyone who is maybe not from our class, but is using this as to help them in their lesson, I'm sorry to tell you, but we are going to be doing a different sheet right now. What we're doing here on this sheet is we are practicing a little bit more on how to read line plots. So I'm going to kind of help you through some of this. We'll see how much time we have all together, and we'll do as much as we can. This picture here is of another line plot, and these X's represent students who have taken tests in science. It's a science test scores. Mr. Bradley is very proud of all of the students in his science class. They all studied hard and did an excellent job on last week's science test. Everyone in the class scored an 88% or higher. That's good. The line plot below shows the score distribution. So here we have children who scored 88%. 1, 2, 3, 4. Children, 2 here who got a 98. Wow, that's almost 100%, which means nothing wrong. And 2 kids got 98%. So now they're going to ask us a few questions to match this line plot. We will do some of them, not all of them, because this should be your homework sheet. Let's do some together, though. Number 1 says, how many students received a score of 94? Well, that's not so hard. Let's go look for 94. There it is. How many X's are above? 1, 2. So, 2 students. Number 2. What was the highest score in the class? So you're going to look and see where is the highest score that an X is over. Number 3, what was the lowest score? Same thing, go down and look for the lowest score that has X's above it. Number 4, how many students received a score in the 80s? Let's do that one together. So I'm going to look at the 80s. Oh, that would be 88 and 89. And let's see how many students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 students that received a score in the 80s. You are going to do the same thing for number 5. How many students received a score in the 90s? So any of the X's that are in the 90s, you're going to count all of them up. See how many. Number 6, how many students scored 93% or less? Oh, so that means that we're going to start with 93 and then go backwards and see how many all together. So including 93, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 students who scored 93 or less. Number 7, how many students are in Mr. Bradley's science class? Well, all you need to do is count up all those X's and you'll see how big his class was, how many kids were there. Number 8, I'm going to help you with. Number 8, Mr. Bradley decides to give each student 2 percentage bonus points. That's like extra points. 2 extra points on their last test for participating in class. Explain how you could change the graph to show the new test scores. So if every student were to get 2 more points, what would this line plot look like? Basically, if you had a 98 and you added 2, you'd be at 100. So there'd be 2 X's over the 100 now. If you had a 97 and you add 2 to it, that would be 99. So all these X's would be over the 99. What we're trying to say here is that every single score would increase by 2. And you would show that on your line plot. Every group would be increased by 2%. Let's write that down. I'll just say student. Every student's score would increase by 2 . So I would redo my line plot to show that. Okay, so we had a very short lesson for today. We just did page 459, 460, and then we did a little more practice on this review sheet. Good job. I'll see you guys later.